Right, lesson 4, onwards and upwards. So if I am asked to solve for x, my thought process would be, is this a right angled triangle? So I could use Pythagorean theorem or SOHCAHTOA. No, doesn't look like it. Second thought is, can I use sine law? And I would need an angle and side pair across from each other that are complete. I don't have that in this triangle. This angle is the only one that I have, and the side across from it I don't have a number for. So I can't use sine law for this one. So I'm a little bit stuck. What I'm going to do to start is to show you that you can always use SOHCAHTOA in a problem. It just might take a little longer. So I'm going to drop a height into this triangle and say, all right, I'm going to form two right triangles. The little skinny guy at the top has a right angle and a 40 degrees, a length of 16. I could use it to find this side. I'm going to call it y, and then use y and the 20 to find the x. Okay, let's solve for y first. If I want to solve for y, I'm going to use that angle of 40 degrees as my angle of reference. Y is opposite to it, and the 16 is the hypotenuse. So I'm going to use the sine ratio. Sine of 40 degrees is opposite over hypotenuse, so that would be y over 16. If I multiply both sides by 16, I will have my length of y. Okay, side y. Always checking them in degrees here. Times the sine 40 is 10.3-ish in length. Okay, if I have this length is 10.3, then in my bottom triangle, I could use the 10.3 and the 20 to find the length of x. How would I do that? I don't have any angles in there. Well, the other tool that I can use with right angle triangles is Pythagorean theorem. So my 10.3 squared plus, whoops, how long is that side? I've got a problem. I need to figure out how long this section is, and it's not fully 20. So I have to backtrack for a second. I need to find little a, which ends right here, so that I know how long that side is. It's not 20. Okay, backtrack over here to solve for a. With my diagram, it doesn't look like it's very long, but you never know. So using that angle of 40 degrees again, I have the 16, which is the hypotenuse. This time I would like to find little a, which is the adjacent side. If I want adjacent and have hypotenuse, I'm going to use the cosine ratio. Cos of 40 degrees is little a over 16. So my little a is 16 cos 40. $12.3, longer than it looks. So if a is 12.3, then I am left with 20 subtract 12.3, which is 7.7. So if I have a 10.3 and a 7.7 and I want to look for x, then I can use Pythagorean theorem. In the blue triangle, x is the hypotenuse. So we would set it up, x squared equals the other two sides squared. X squared equals 10.3 squared plus 7.7 squared. 165.38. To find the length of x, I would take the square root. That was approximated already, wasn't it? Okay, square root So that number is about 12.9. That took a fair bit of work. We can always use right trig if you drop a height into triangles. You could use sine law sometimes for non-right angle triangles. Today we're going to introduce the last tool for acute triangles called the cos law. I have often called it coleslaw, and I'm trying very hard not to do so. So the cos law is very similar to the Pythagorean theorem with a twist. So the cos law, sorry, I'm going to set it up with C, A, B's, and C's. Pythagorean theorem looks like this. C squared equals A squared plus B squared. The cosine law starts the very same, but we get rid of a little piece. C squared equals A squared plus B squared. Subtract 2 times A times B times cos of the angle. Let's not put a 40 in there. That's only for this particular problem. Cos of the angle. The important thing to remember with the cos law, similar to the sine law, is that this is across from this. Triangles are all about opposite ratios. So if I'm going to use the cos law for this problem, I want to solve for x, and it is across from the 40 degrees. So I'm going to start the cos law with the x squared, and I'm going to end with 40 degrees. Right, let's set it up. X squared equals the sum of the two sides squared, subtract 2 times 16 times 20 times cos 40 degrees. The trick with this is not the law itself, you'll remember that fine, but is to remember to multiply all of this. A good tool to use would be 16 squared plus 20 squared, subtract bracket 2 times 16 times 20 times cos 40. Okay. Is 165.73. And the square root of that would be, you'll be shocked by this, but it's the same answer as last time, approximately 12.9. Okay. We're going to use the cosine law to solve for theta. All right, we want this angle, theta. It is across from the 3.2, so those are the opposites I need to think about when I'm setting up my cos law. I'm going to write the cos law down, and then we'll put the right numbers in the right spot. Okay, since it's theta that I want, I have to start my cos law with that 3.2. So 3.2 squared equals the other two sides squared, subtract 2 times the other two sides, cos theta. All right, you ready? This is the tricky part. I want to get cos theta by itself. So I am going to get rid of the two add-ons first. So I'm going to do 3.2 squared subtract 5.9 squared subtract 6.2 squared equals negative 2 times 5.9 times 6.2 cos theta. All right, let's get our calculators out and get an answer for that left side. 3.2 squared subtract 5.9 squared subtract 6.2 squared. Okay. Negative, now that's just weird. Negative 63.01 equals. I'm going to multiply those three numbers in front of cos theta to just try and tidy that up a little bit. Negative 2 times 5.9 times 6.2 is negative again 73.16 cos theta. Getting there. I want to get cos theta by itself so I can find theta. So I'm going to divide both sides by 73.16. Okay. You don't need to write down all of these steps, but I am going to do so for this example. Negative 63.01 divided by negative 73.16 is decimal 86126. And we're rounding. But if I want an angle and I have that decimal, I'm going to do second function cos, which is the opposite of cos. And I will find my angle. Which would be 30.5 degrees. So the big idea is it's a little bit harder to find an angle using the cos law, but in the same way we need to have the side at the beginning is opposite to the angle at the end. And then we just carefully get cos theta by itself. One last question. We have Ken. Cell phone detects two transmissions antennas, one 7 kilometers away and the other is 13 away from his position. The two antennas appear to be separated by an angle of 80 degrees. I see 4 typos in that question. I apologize. How far apart are the two antennae? Okay, so here's Ken and his cell phone. There. Two transmissions, one is 7 and the other is 13. So let's have transmission tower 1 and number 2. Not to scale. He thinks it's 7 and he thinks it's 13 kilometers away. They appear to be separated by an angle of 80 degrees. And we want to know how far apart the two antennas are. Okay. So my thought process would be, can I use Pythagorean theorem or SOHCAHTOA to solve this problem? No, it's not a right angle triangle. Can I use sine law? No, I don't have an angle and side pair complete, so that one of my ratios would be complete. I'm stuck with the cos law. So the cos law would say I need to begin my cos law with the opposite side to the angle that I have. So I'm going to start my cos law with the x and end with the 80 degrees. So let's fill in the rest of the pieces. We have 7 squared and 13 squared, and then subtract 2 times the 7 times the 13 cos 80. This one's nice because I have the angle, so I just need to carefully type that in. 7 squared, 13 squared. I would recommend you use your brackets. 80, talking to myself, is 186.4, approximately. If I want to find x itself, I have to take the square root. And I get 13.7 meters apart.